So so why does it matter? Like we've seen like in the in the snarkified section projects, we have like zkTLS, passport projects, even national identity card projects like Anon Aadhaar and EU ID projects. So all of the projects have something in common, which is like signed data, and the signed data are like signed by official government or different entities. So one of the unexplored part was like PDFs. So this project about like proving data rich statements within PDFs. So you could able to prove Web2 data into Web3. You could able to prove port Web2 data into Web3. So this like so yeah. So what are the use cases for zkPDF? So the important use cases for zkPDFs are like finance and KYCs, and also like you could port Web2 data into Web3, and you could prove financial transactions. You could prove digitally signed documents by your government or any entity such as like DigiLocker or DocuSign. So what are the example statement I could like prove right now? I can prove I own a degree from like college without revealing the entire like full document. So you could like prove that you did a transaction from person A to person B with some bank, and you could do all of this stuff. So you could do age claims as well. Like let's say you have like a PAN card document and you wanted to prove with the PAN card is the age is above 18. You could do that right now with zkPDF stack. So yeah. So why does it matter to like who signs this document? So one of the important intuitions for us to understand is like who signs this document. So for any like documents, so the signer is the authority who signs the document. Let's say in the case of DigiLocker documents, you could like download all the documents from financial documents, from your financial, legal, all the driving license documents from DigiLocker. So Indian government sign this sign all of the PDFs for you, and they use the same key to sign the documents. So in theory, you could just like port the public key out, and you could like prove whether this document is signed by Indian government or not. So this opens like new era of like data-rich statements. You could like prove all of this within the zkPDF stack. And financial institutions such as like banks like insurance provider, they use this zkPDFs. They use this signing mechanism all over the PDFs. So yeah. So how does the zkPDF stack works? Generally, when the user uploads a PDF into the app, so the PDF sends this input signals or inputs to the prover. In our case, the zkPDF has the remote SP1 prover, and once the SP1 prover gets the inputs, now it will generate a proof for you. You can generate a PlonK and Groth16 proof within the prover, and you could generate proofs within the circuit. And once you get the proof, you could verify this proof in any EVM-compatible blockchains such as like Arbitrum, Ethereum. So the verifier is a smart contract, and the circuits are in like SP1 circuits. You could like put the zkPDF crates into SP1 circuits, and you could like prove all of the statements inside zkPDF stack, and you could put all of these proofs into verifier contracts. So what are the current limitations for zkPDF stacks? Currently, the proofs are generated over server side. So completely, we are partnered with Substring Labs for Pro network access. So if you want to generate proofs, you could currently you have to use SP1's Pro network to generate proofs. And why not client side? There's like a heavy computation to perform the zkPDF, put the zkPDF stack into client-side tech, because we have to hash like megabytes of data, and we have to prove all of this inside the zk snark, which is not feasible right now. So that's the reason we are sticking to client-side stack. So in the upcoming months, we are actually working on making the zkPDF stack completely client-side. So yeah, this is all about like zkPDF. So let's say you wanted to verify whether the PDF is signed by any entity or not, and you wanted to verify whether it is compatible with zkPDF stack or not. So this is this website which has this compatibility check, where you could do. There are two methods actually. One is extract plus verify, and the second method is substring with offset. So what I have is like, let's say I have this document called GST certificate. Generally, so currently what you can see is like it says like it is compatible with zkPDF stack, and the signature is valid, and this is the same public key which is signed the document, and you could see all of the extracted information, which is like registered number, all of the legal name and like train name, all of this information. So this PDF is digitally signed by Indian government. And let's say I wanted to verify. So the first part is like extract and verify. So what it does is like it extracts the signature from the PDF and it will verify the signature from the PDF content, and it will it will send your output for all of the text. So if I click on, so it's also already verified. So what the second method is like, let's say you wanted to prove some content. Let's say I wanted to prove, this is the train name I wanted to use. What I could use is like, I could like keep it here, and I wanted to select the page number because there are multiple pages in this PDF. And let's say you wanted to verify whether this substring is in the main PDF or not, you could like do verify check. So it says like text, consumer entity and trust association found at offset 307. Generally, offset is the index of the string, where this is the entire string. It is an offset where you wanted to check whether the substring is present in the main string or not. So this is the compatibility check where you could verify whether your PDF documents is like compatible with zkPDF stack or not. The second part is like, we have like bunch of circuits. So this is the main repo, and main repo has this package called zkPDF lib. So you don't need to like set up the entire repo. You could just set up the SP1 template. So currently, so the SP1 template looks something like this. So you need to set up env variables. You need to get the network private key. So once you generate a private key for yourself, you need to send me the public key address, so where I can whitelist you for the ProNet access. And you need to change this SP1 Pro to network, and then it should be good to go. You could like able to verify zkPDF proofs within this template. So I'll quickly explain what's the intuition behind like all of these things. Let's say for any circuit, you have inputs and you have outputs. So for inputs, you have the input for the this certificate is like, you have the entire PDF bytes. So we are inputting the entire PDF byte, and we are outputting this struct, which is like a GST number and like a legal name, and whether the signature is valid or not, and with the document commitment and public key hash. So you could verify whether the document is signed by Indian government or not with this public key hash parameter. So the lib is like a Rust crate, and program is for the circuits, and samples is a GST PDF. This is a sample document which is signed by Indian government, and these are the scripts. And the scripts, so there are like two ways you could generate proof. One is like a core proof, which generates within the local server side setup, and the second is like a ProNet. So if you want to utilize the ProNet, I have like abstracted on the API server for you. You could just like run this command. It will create an API server for you, where you could send proof requests to the succinct prover network. There's a little demo which I have. So right now it's like a HTML file. So this is a sample website. So what I need to do is like, I need to give the entire GST certificate. Okay, so once you have the certificate, so what I'm doing is the verify and extract method instead of offset for the simplicity. So let's say you click on generate proof. What it does is it sends the entire PDF inputs to prover network, and it will compile the circuits, and it will send to it will generate a proof for you. So you can see like there are like these are the like gas limits, and this is a cycle. So you could like you could see your proof requests in the Explorer. So it generally takes like around 20 to 25 seconds to generate like a groth 16 proof. So yeah, so once this proof is generated, you could like get the proof on the website, and then you can, with the proof, you could like generate on-chain commitments, and you could verify whether the proof is valid within smart contracts, and you could verify proofs on the two methods. One is like on-chain, one is off-chain. So yeah, like you could verify these proofs. So let's see whether the proof is generated or not. So while the proof is generated, I quickly explain like two methods. So we have a documentation for all of the zkPDF API. So if you look at API references, let's say there are like two important methods we need to understand. One is like a verify text, and one is like a verify and extract. So let's say you wanted to build some custom circuits. Let's say you wanted to prove you did some bank transaction from person A to person B and with some specific amount. In that case, what you need to do is like you need to verify the signature, the first step, and then you need to extract the signature. You need to verify this, extract the signature, and you need to extract the commitments, and then you need to extract the text as well. Once you have the text, you could like generate like string manipulation or regex techniques to scrape out the content you want to tackle. Something like here, like in the current certificate, I'm like snark. I have this program where it takes this regex patterns. It will get me like a exact string for GST number and like legal name. So once we get this parameters, we could able to commit to onchain. So as you can see, we have a proof generated. This is a gross 16 proof. So these are the public inputs, and this is the encoder proof, and you have like a raw proof, which is like this is a wiki hash, and this is a verification key hash. So yeah, so once you have this proof, you could verify this proof within this contracts folder. So this is a simple contract which verifies this GST proof, which has this exposed method called GST verify GST method. It will take public values and proof bytes. What it eventually does is like it will verify gross 16 proof first with the verification key, and the second thing, it extract all of the public values. So once we have the public values like GST number, legal name, signature, if the signature is valid or not, and the document commitment and the public key hash. So I'll quickly explain what are the commitments, why we need to use these commitments. So let's see. So here we could see like, so document commitment, let's say you have like multiple apps where you want, you have like multiple proofs. So what we can avoid is like you could gatekeep the proof to use like only once at a time with its document commitments. And if you see the construction of document commitment, it's like hash function of some message digest and sign data and like few nonce. So if you see document commitment, it's like message digest, GST number, legal number, and signature. So for every PDF, this is like unique. So you could able to deterministically generate like a commitment, and you could able to use that commitment to avoid multiple proof validations. So yeah, this is pretty much about like SP1 zkPDF template. So yeah, so there are like few other API methods as well. One is like extract text, which only extract the text from the PDF. It doesn't verify any signature. And the second method is like verify signature. So the verify signature take all the PDF bytes. It will return a type called signature result. So this function verifies the signature, and like it will tell you whether the signature is valid or not. So there are like few supported. The lib only supports like RSA with SHA-1, SHA-256, and 384 and 512. Currently, we don't support ECDS signature. And like, let's say if your PDF has like the chain of authority, let's say it's signed by 2-3 public keys, we don't have support for that. So we'll quickly see what are the FAQs for that. Any FAQs? So what are the PDF formats like we support? First thing, the initial check should be that it should be digitally signed, and the second should be like we don't support like images, we don't support form fields, ECDS, and complex layouts. Like you have like an image, you have some code. Like we don't support all of these things. The most of the things we support is like text extraction and like signature. And like we have like multiple page document support, and we have like compressed themes. And let's say if your document is like a different language like Chinese, Japanese, we do support that as well. So these are the signature algorithms supported. So also like one of the important questions we got was, can I run zkPDF on the client side, like somewhere like truly client side over mobile or browser? Currently we can't because of the hashing complexity in the circuits. So yeah, so how could I like integrate zkPDF within the application? So at the end of the day, you could like make a API, simple API, which takes a PDF input and it outputs a proof for you, and you have like some smart contracts deployed over EVM chains, and that should be good. So there are like few instructions for deploying your contracts as well. So you have like, you could, so these are the pre-built contracts. You could just use all of these contracts. Yeah. So this is a link tree. We have like a Telegram group, and this is a compatibility check, and we have like a documentation which has like all of the proving API. Let's say you wanted to get access to Substring Pro network. There's a form as well. So please fill the form, and like you have to fill your team name and your public key details. And once you have that, like you need to go to SP1's Explorer page, and so you need to connect to SP1's Explorer page, and you need to collect your wallet. So there are like two websites actually. One is like explorer.substring.xyz and like explorer.resolve.substring. So we are using this network. So we'll quickly like, so you need to like sign this request. So once you have signed into this, so you could see all of the proofs and all the transactions you created. So we have like a limited credits for hackers to play around with in the SP1 network. So on the regarding the benchmarks, so we do have like a benchmarks. I'll quickly show the benchmarks. So these are the benchmarks. This is a proof size, and so one the PDF is like RSA-SHA 1, and the second PDF is like PlonK document from DigiLocker. So it uses the same Substring version, and it takes around 52 seconds, and the second PDF takes like 31 seconds to generate the proof, and these are the number of cycles, and this is the gas cost. So you could like quickly go to the blog section. We have like bunch of docs, and we have like a bunch of templates you could play around, and we have like a set of like PDFs you could play around. Yep, I think this is pretty much it.